In this video, we're going to be going over how to solve problems using z-scores, okay? So here I've written the problem, and I'll read the problem, and then we'll get into solving. So find the mean, x bar, and the standard deviation, sigma, for normally distributed data if 1.1% of the data is less than or equal to 7.84, and 50.8% of the data is less than or equal to 17.8. Okay, so it's normally distributed data, which means that we are able to use our z-score table, okay? So, firstly, we have 1.1%, okay? So, 1.1% of the data is less than or equal to 7.84, okay? So, what is the corresponding z-score value for 1.1%? Well, 1.1% in decimal form equals 0.011, right? To go from percentage to decimal form, you just divide it by 100, okay? So these are the same thing. Now, I'm going to take a look at my z-score table and look for the value 0.011, okay? So I find 0.011 at negative 2.29, okay? So z equals negative 2.29. Okay, good. I have that. Now I also know the formula to find a z-score, right? Z equals x minus x bar over the standard deviation, okay? So I'm going to write that now. So I know that negative 2.29 equals x, so 7.84, minus the mean, which we also don't know, over standard deviation, which we also don't know, okay? So that's our first equation. Good. Now we have 50.8% of the data, which in decimal form, of course, is 0.508, is less than or equal to this number, okay? So let's find the z-score for 0.508. 0.508, okay, that's 0.02, okay? So z equals 0.02. Okay, and then our equation for this would be similarly to the other one, 0.02 equals x, so the number that's less than, so 17.8, sorry, 0.08 minus x bar equal over sigma. Okay, so now we have our two equations set up. All we have to do from here is we have two equations. We can isolate for one variable and then sub it into the other equation, okay? So that's what I'm going to do. On this side, if I multiply both sides by sigma, right, I can go times sigma here, okay? These ones will cross out, and now I have negative 2.29 sigma equals 7.84 minus x bar. I could divide both sides by negative 2.29. And now I've isolated for standard deviation, right? So standard deviation equals 7.84 minus x bar over negative 2.29, okay? All I've done here is isolated for one variable. Now, I will also isolate for this variable on the same side. I could do this a quicker method. Multiply both sides by sigma and then divide both sides by 0.02, and I'll get sigma equals 17.08 minus x bar over 0.02. Now, if standard deviation equals this and standard deviation equals this, well, that means this equals this, okay? So new equation, 7.84 minus x bar over negative 2.29. Here, let me just mark this off, show you that this is a new equation. So that's this, right? Equals this. Equals 17.08 minus x bar over 0.02. Okay, now I'm going to cross multiply, so 0.02 times 7.84. That is 0.1568 minus 0.02 x bar equals negative 2.29 times 17.08 negative 39.1132 plus, because negative times negative, plus 2.29 x bar. Okay, now I'm going to add this number to both sides. So we have 0.1568 plus 39.1132 gives me, gives me 39.27. And I'm going to add 0.02x bar to both sides. So that equals, 2.31 x bar. I could divide both sides by 2.31. Gives me 17. 17 equals x bar, okay? 17 equals x bar. We already have this equation, so if I put in 7.84 minus 17 for x bar, all divided by negative 2.29, that gives me also that standard deviation, or sigma, equals 4, okay? So using z-scores, we were able to tell that the mean is 17 and the standard deviation is 4. Quickly to summarize, what we did was we found the corresponding z-score for the percentage that we were given in the question, right? 1.1 and 50.8. Z-score was negative 2.29, z-score was 0.02. Then we figured out the z-score equation, which is z equals x minus x bar over sigma. We plugged in our values. We isolated for sigma for both equations. We equated them to find x bar, and then we subbed x bar back into one of our sigma equations to find sigma, okay? So x bar is 17, sigma is 4.